Okay, in this video, we're going to review all the rules for exponents and be able to use any or all of them to simplify an expression. Okay, so here's a simpler one we're going to start with. Let's look at that and see what we would do with it. Well, remember the power rule says that the 3 and the negative 2 get multiplied here. So that's x to the negative 6 divided by x to the 5th. And then we apply our little phrase, cross the line, change the sign. 1 over x to the 11th power. That would be, if I cross the line, well, let me do that in separate parts there. We would cross the line with this x to the negative 6, make it x to the positive 6. So they're both down here together. Therefore, they are multiplied. We apply the product rule to that, and we get x to the 11th. That's the answer to that one. So we used a couple of different rules there. Let's review all of those rules before we attack something complicated like this. For all these rules, if x, y, p, q, and r are all real numbers, then these apply. The product rule for exponents is x to the p times x to the q would equal x to the p plus q. The zero exponent rule, x to the 0 equals 1. The negative exponent rule, x to the negative p equals 1 over x to the positive p, or x to the p power. Remember that x cannot be equal to 0 there. The quotient rule says that x to the p divided by x to the q would be equal to x to the p minus q power. Again, x cannot equal 0 in that case. The power rule says the quantity x to the p raised again to the q power means we multiply those exponents and get x to the p times q. The power of a product says if we have xy in parentheses raised to the p power, that the p can be distributed to each of those factors. It would become x to the p times y to the p. And also, if it's more complicated, if we already have x to the p, y to the q inside parentheses and raise all of that to the r power, the r gets distributed to the p and then to the q, and we're left with an answer that looks like x to the pr times y to the qr. And finally, the power of a quotient is similar. X over y, all to the p power, is equal to x to the p over y to the p. And if that's more complicated, if it's in parentheses x to the p over y to the q, all raised in parentheses to the r power, that r would distribute to the top exponent and the bottom exponent and get x to the pr over y to the qr. So let's use those rules, any that we need to simplify something complicated like this, at least more complicated. One thing I want to mention right off is that anything that doesn't have an exponent, like this 3 and this 6, really does have an exponent of 1. So we have to keep that in mind. Don't forget to put this exponent, as we distribute it through this entire rational expression, with each exponent that you see here, now that we've put the ones in there. And that's only one way to do it, by the way. There's lots of ways to deal with this. We could simplify inside the parentheses first and distribute the negative 2. And that might be a little quicker in some respects, in some problems than others. Let's do it this way for this one, though. I'm going to distribute that negative 2 to every exponent that's inside here. So that becomes 3 to the negative 2, the first one. X to the negative 3 times negative 2. Negative 3 times negative 2 is negative 6. Oh, sorry. 2 negatives multiplied to get a positive 6. Y to the 5 times negative 2 is y to the negative 10. And there's the fraction bar divided by. And the negative 2 goes to each one of these exponents as well. So we have 6 to the negative 2, x to the negative 10th, and y to the positive 16th. So that's our first step. We've distributed that negative 2 to all of those factors and multiplied it by their exponents. Now, here's our line. Let's cross the line and change the sign with any of the negatives, because in these problems, remember, they ask for the final answer to be written only with positive exponents. So we're just going to make all these positive by pushing them across the line. So the 3 to the negative 2, I'll put the bar down first. It crosses the line, goes to the bottom. We got 3 squared. The x to the 6th can stay up there. The y to the 10th, negative 10th, would cross the line and become an exponent, power down here, y to the positive 10th. Then on the bottom, the 6 to the negative 2 goes to the top. We'll put it in front here, because we're used to seeing numbers in front. And the x to the negative 10th crosses the line to the top and becomes x to the positive 10. And the y to the 16th stays on the bottom because it's already positive. Okay? So we applied that negative exponent rule and just pushed things across the line, changing the sign on the exponent. Now we can simplify. What's 6 squared? Well, that's 36. And x to the 6th and x to the 10th, the 6 and the 10 add together to get 16. And on the bottom we have 3 squared is 9. And these are both the same base too, so we can add those exponents. 16 plus 10 is 26. And is there anything left here to simplify now? Well, we have different bases, x and y, so we can't do anything with the variables. But 36 divided by 9 is a simpler number, 4. So that's 4x to the 16th divided by y to the 36th. And that's your answer there.